Moin! Today we're building this sword. For those who don't know it, it's a prop from the Lord of the Rings. It's the largest 3D printed and then electroplated object I've made to date, and it presents quite an interesting challenge. But it's worth the effort because it scores with an incredible metallic shine and unique physical properties. So let's get started. As always, let's begin with 3D printing objects. I downloaded this sword from Thingiwares. You can find the link for it in the description. In this case, the sword consists of 4 parts, which I printed with a resin printer. The whole thing is very big and heavy, but a resin printer gives me a very smooth and easy to grind surface. All things that are beneficial for the later electroforming. The procedure is always the same: printing, cleaning and curing. Funny is that the individual parts in the UV curing somehow already strongly remind of the Lord of the Rings. The next extremely important step is that the parts are carefully deburred and sanded. I know I'm repeating myself, but the most important thing is a flat surface. There's no way around it. Therefore, we now use everything in our power to make the parts as smooth as possible. Use sandpaper, for example. Finally, use steel wool. Remember your safety. Wear a respirator during the entire process. And after what feels like 48 hours of sanding, you will have beautifully smooth parts. Now get a M8 threaded rod or 5/16 inch and put the pommel, the handle and the crossguard on it. Measure the depth of the blade and trim the threaded rod. So now you have the finished resin sword. Let's see what the individual parts weigh. Now it is time to electroform the parts with copper. My 5-liter container is too small for the parts, so there has to be a larger tank. 15 liters should be enough. In with the acidic bright copper electrolyte. I expect currents between 7 and 9 amps, so my 5 amp power supply is no longer sufficient and the big one will be needed. This can provide a maximum of 30 amps. Also, my small copper anodes have to be replaced by much larger ones, but this is not really necessary. The surface area of the anodes should be slightly above the surface area of the object to be electroplated. I can only advise everyone to make anode pockets. These prevent the waste material from the copper anodes from getting into the electrolyte and depositing on the parts. This is quickly done with a pond filter and a hot glue gun. Now we can spray on the copper conductive lacquer. Spray this well diluted thinly with an airbrush. Make sure not to miss any spot. Wait a bit until the paint is dry and connect the galvanic bath. At this point, I always refer to a video where I explain this in detail. Wrap the piece with copper wire and optionally hang it on a rotary jig. Then set the current to 0.2 volts and electroform the whole thing for 4 hours while you slowly increase to 1 volt. Uh-oh, rough surface, probably from too little contact area of the wires and too fast impatient plating. Happens from time to time. Fortunately, it can be saved and it will be covered by leather later. I should be more careful next time. So watch out, the next part, the pommel, goes into the bath. Here everything went quite wonderfully. A nice thick copper layer with few flaws and impurities. Still not completely perfect though. At this point I realized that the 15 liters probably couldn't be enough for the largest two pieces, so an even larger bath was needed. I doubt it was really necessary though. I then electroformed the last parts, but it didn't come out really super smooth. I'm going to follow up on that, but I think I'm still doing something wrong. Nevertheless, they all turned out to be quite good. Each one can be quickly polished to a high gloss with a little finishing, and that's what matters to me in the end. Before we start, I weighed them again to see how much copper was actually deposited on the resin print. 367 grams became 424 grams. It's about 55 grams of weight increase, and thus the sword became 60% heavier. Now I polish all the pieces I have. Some parts, like the pommel, I have only treated with polish, others again with the full range, until I had a really shiny surface. Remember these? Let your creativity run wild. The material can take it, don't worry. Now I'll electroplate the decorative layers. I took the sword apart, cleaned and degreased it thoroughly, and will now apply a thin layer of nickel. Nickel sulfide is not to be messed with, which is why I permanently wear a gas mask and gloves in my well-ventilated room. Instead of nickel, you can also work directly with the much safer Palladium electrolyte and a Galvanic brush. The nickel plating process is basically like the copper plating, except it only takes a few minutes. Again, I wrap the parts in copper wire and hang them in a bath with a nickel anode and a slightly higher voltage. In doing so, I avoid the formation of bubbles. In many YouTube videos the nickel baths bubble like crazy. Do not do that. Adjust the voltage just before bubbles form and you're all good. As nickel is a contact allergen, I will now apply a thin layer of Palladium to the entire sword. The optical difference is slight. Palladium always seems a little bit more grayish to me. Now something new and cool. I bought this, it's called a Galvanic pen. Basically something like a felt tip pen in a hollow graphite anode. I can dip the felt in gold electrolyte, then connect the pen to my power supply and gold plate the small details on the sword. It's very nice. I still have to mask though. Now only the handle is missing. Sure, you can wrap with insulating tape, but I think if you already make all this effort, then you can finally invest some time and build a handle with Leatherette cover. Fortunately, it's pretty simple. Cut it out, glue it on and airbrush it. And now we are ready. Just quickly screw all the parts together and fix them. After that, we can present it. But what are the great physical features? Because it is pure metal and not paint, it can be easily washed and dried. It is pretty scratch resistant and extremely sturdy. You shouldn't try that, actually. Well folks, that's it. I'm glad I finally got to do this. It was kind of a test for the really big parts like helmets or so, but that's another story, probably soon on this channel. Here are a few more impressions. Take care and tschüss.